I'm Ahmed Daud, and in this session, we are going to see precision recall trade-off. In the last session, we have seen precision recall F1 score. We have discussed that where we care more about the false positives, we usually use precision as the evaluation metric. When we care more about the false negatives, then we use recall. And when we care about false positives and false negative equally, then we use F1 score. So in this session, we will see in detail the more precise idea of the use of precision and recall. So first of all, we usually have this type of equation for logistic regression, 1 plus e raised to power minus mx plus c. And we usually call this p cap the probability of belonging to class 1. Okay, and if p cap is greater than equal to 0.5, we say that it's this sample is belong to class 1, and if p cap is less than 0.5, then we usually say that this sample belong to class 0. Okay, so now come back here. Okay, so you have seen this data in which we have true values, about 300 true values against we have some predictions, and this is probabilities for the class 1. Okay, in other words, you can say this is the same as the p cap. Okay, so if I will make this one okay, so this prediction works in the way of using the threshold, default threshold, which is 0.5. So if the probability is greater than 0.5, then it will be classified as 1, like here. And if probability is less than 0.5, like all the other samples, it will be classified as a class 0. Now, uh, just think in other way, if we will change that threshold instead of 0.5, if we will have a threshold 0.7, and we say that if the probability belonging to class 1, this one, greater than equal to 0.7, then the sample will be considered as a 1. Otherwise, if the probability less than 0.7, then it will be considered as a sample will be considered as a 0. Okay, so here you will see there is no any probability which having greater than 0.7 or equal to 0.7. uh, all the probabilities are less than 0.7, so all the samples that we are visualizing here are having the sample 0. Okay, like all this all will have sorry, if I will here, you can see when you have a probability 0.7, all become 0 0. This will also become, because it is less than 0.7, this probability less than 0.7, so here it will become 0. Okay, so if and you can get an idea that if you will raise the threshold, your number of positives will decrease and your number of negatives will increase. Okay, here you can say your predictions about the ones will decrease and zeros will increase. The reason that when you are highly confident that this sample belong to the one class, let's say if you are 70% sure that this sample is belong to one class, then you are classifying as a one, otherwise you are classifying as a zero. So your probability, so your number of zeros will increase in the prediction column and your number of ones will decrease. When your number of ones will decrease, your true positives also will decrease and false positives will also decrease a lot. The reason is that when you are highly confident that this sample belong to the uh, positive class, then you are classifying as a positive. Otherwise, you are not classifying. So that's why your false positives will also decrease. And true positives, of course, decrease, but this is not due to confidence. These true positives are decreasing naturally. When you are increasing your threshold, you are, of course, you will have less number of probabilities in your data that having a probability greater than 0.7. Okay, and usually the samples that have high confidence, high probabilities, uh, like greater than 0.7 or 0.7, they are surely belong to the one class. So that's why our false positives will also decrease. So your number of zeros will increase, then your true negatives will increase, and your false negatives increase a lot. The reason is that if you are not here, you can see if you are highly confident about the sample that it belongs to class 1, then you are classifying as 0, as 1. Otherwise, you are classifying all the samples as 0. In other words, you will see if you want to write this in the form of one class, this is probability greater than 0.7, and this probability is probability for the class 1. Then you say that it belongs to class 1. And if you will write the probabilities for the class 0 that usually sklearn have in this way, 1 minus p cap, and here you are saying that, yeah, here you are saying if your probability belonging to, this is the probability belonging to class 0. Okay, so if your probability belonging to class 0 is greater than 0.3, then the class will be classified at 0 if you have set the threshold at 0.7. Okay, so here you got an idea when you are very less confident about the sample that it belong to class 0, you classify as 0. Okay, when you have increased your threshold 0.7. Okay, so you have seen that your true positives increase, true positive decrease, false positives also decrease, but a lot. True negatives increase and false negatives also increase a lot. Okay, and in the opposite way, if you will decrease the threshold to, let's say, 0.3, then the values will work in the opposite way. Okay, so when you are just 30% confidence that sample belong to class 1, you will classify as a 1. Your true positives increase, but your false positive will also increase a lot. The reason is that you, when you are just confident, 30% confident about the sample that belong to class 1, you will classify as a 1. Okay, so there is more chances that you will get false positives. Okay, so here we will discuss what will be the effect of setting increasing threshold or decreasing threshold. This is by default that we usually having 0.5, but if we will have threshold 0.7, then you have seen that if we are increasing our threshold, our true positives and false positives are decreasing, and true negatives and false negatives are increasing. Okay, so what will be effect on the precision? Precision have precision usually consider false positives. Okay, so true positives decrease. True positives also in the denominator, it is decreasing, but false positives decreasing a lot. So there is a very less value. This will maintain the ratio, but this will be very less in the denominator. So that's why your precision overall will increase when you will increase your threshold. Okay, so in the case of recall, your true positives are decreasing, and your false positive, here your false negative will increase when you will increase your threshold 0.7. Okay, so your recall will decrease. Okay, you got an idea by increasing the threshold, by increasing the threshold, precision will increase and recall will decrease. And in the other way, if you will decrease your threshold like 0.2, then your number of positives will increase. Okay, your number of ones will increase, true positives also increase, and false positives are increase. And I have told you the reason, because when you are very less confident, about 20% confident that the sample belong to class 1, you will classify as a 1. Okay, so here your number of zeros will decrease because you have set the threshold very low, and true negatives will decrease and false negative decrease a lot, because you will classify sample as 0 when you are highly confident that this sample belong to 0. Okay, so here what will be effect on the precision and recall? If we will first consider precision, true negatives over true negatives plus false positives, and recall will be true positives over true positives plus false negatives. Okay, so here you will see when you will decrease the threshold 0.2, your true negatives are here decreasing. Sorry, it's a true positives. These are true positives. Your true positives will increase here. Your true positives increase and false positives also increase, but a lot. The reason is of false positive increasing a lot, the that you are classifying samples as one with low confidence. So your precision will overall decrease. Okay, because your false positives will increase here and your recall will increase. The reason is that your false negatives will decrease a lot here. Okay, and when you as I told in the last session, that when you care more about the false positive you usually use precision, and when you care more about the false negatives you usually use the recall, and you are visualizing here the effect with the increasing of one error, how these measures are changing here. Okay, so you got an idea. Now there is another angle to visualize the problem, that you can if you will move the threshold from 0.5 to higher direction or lower direction, your precision and recall are changing. So here you will see a practical, the same data here, this data, the same data here, and by default there is a threshold 0.5 and you have this precision. When you will increase the threshold 0.6, your precision becomes 0.5. When 0.7, your precision will become 1. And here, when you have increased the threshold 0.8, there is no any sample that has highly 80% confidence belonging to class 1. So that's why these values are 0. In general way, in mostly cases, we don't have such type of scenarios. Our data sets usually have the samples that are highly confident about the belonging to class 1, but here is the, you can consider till this position less than 0.8, but overall you will see with increase of threshold your precision is increasing here and your recall is decreasing. You can here see 0.16, 0.09, 0.03. Okay, now you will see in opposite direction when you will decrease your threshold from 0.5 to 0.4, you will see here your recall is increasing 0.33, 0.54, 0.78, 0.95. So here you have analyzed that with the decrease of threshold, your recall is increasing, your precision is decreasing. Here from 0.38, here is there is a increase here, but overall 0.4, 0.35, 0.31 overall is decrease. Okay, overall trend you will see from the graph also. So you got an idea that by changing the threshold you can change the precision and recall scores. Now there can be a question in your mind, now how we can select the optimal threshold. So we will see from here. So to select the optimal threshold, there is a, a, a way of considering the precision recall curve. Okay, so here you have seen there is a thresholds on the x-axis and precision and recall scores on the y-axis. Okay, so selecting a threshold, you will have three scenarios here. First scenario is you have to select the threshold with respect to your required position. Let's say you have from your company uh, requirement or project requirement that you have 70%, at least 70% position you should have in your model. So what you will do, at which position you will set a threshold, you will go from here at this position. This position will give you the 70% position. You will go downward and you will select 0.7 as a threshold. Okay. And if your company will say, and at this position you will have 70% position, and here you will have about 10% recall, which is very low here. Okay, so if your company has a requirement that you should have, let's say 80% recall in your model, you will select in this way from this direction. If I will change the color here, okay, so you can go from here from 80%. Here your recall is 80%, and you will go and you will see what threshold is here. 0.2. You will select here 0.2 as a threshold. In that case, you will select about 0. As a threshold, and 0.2 threshold. Here your recall is 80% and your precision is about 30%. Okay. So in this way, you can select a threshold. Okay. By considering the requirement of your project. And if both are equally important, precision and recall, then you can consider F1 score. Okay, F1 score. You can draw a curve against the F1 score. Let's say like this, and here the threshold on the x-axis. Here on the y-axis there F1 score, and where the F1 score is high, let's say at this position, about this position F1 score is highest. You will select this as a threshold. Let's say 0.23 will be your threshold. Okay, so in this way you can select a threshold according to the requirement. Okay, so and you should keep in mind, you in the case of like here the requirement is a precision. You have to select the precision is 70% precision. So you should have select the threshold where the precision is 70% and your recall is maximum. Okay, maybe you have let's say a list of thresholds, a list of thresholds at which your precision is 70%. So you should have select the minimum threshold so that your recall will be high. Okay, so you can also consider in that way precision recall curve. When your recall is on the x-axis, your precision on the y-axis, it's a single curve. And at this position, let's say you want to here how much recall. Let's say you want 80% recall. At this position, your recall will be 80%, and you will get precision 0. About 35% or recall 80%, and at this position you can select your threshold. Okay, you got an idea. You can select the threshold according to the project requirement, how much score you want. Okay, if there is no strict requirement regarding the errors or regarding the scores, okay, or in other words you can say you have to care more equally about both errors, type 1 and type 2 errors, then you can consider F1 score, and you can select the threshold where the F1 score is high. Okay, so now there can be a question in your mind that each model can have multiple precision and recall scores due to different threshold settings. So how you can select a model, or how you can compare two models? Let's say the comparison of like this. If you have a logistic regressor having solver, let's say Newton CG, and logistic regressor solver, let's say SAGA. Okay, if you want to compare both of them, both will have uh, multiple positions, multiple recalls due to different threshold settings. So how you can compare both of them? So there is here you can see this is a precision. Recall is on the x-axis, precision on the y-axis. So this is the, let's say this is the curve. Okay, so I will change the curve color. So let's say this is the curve for the logistic regression and the Newton CG. Okay, so let's say your curve for the SAGA will be like this. Okay, this will be SAGA. So here you can see at each recall, this curve is giving a high precision at each recall. Okay, so you can simply visualize that SAGA solver or logistic regressor having SAGA solver is better than the Newton CG in that case. Okay, so here you can see as you are going towards the, sorry, as you are going towards the top right corner, at this corner your solver or your model will be more becoming better and better. Okay, you can compare, you can select the model which is here having curve more towards the top right corner. Okay, or in other words, if you want to compare in the form of value, or like you can calculate in the form of score, what score this model have, this blue one, what score this green one have, and what score this golden one have. Okay, you can use the area under curve. Okay, you can use the area under curve, like what is the area under the blue curve. Of course, this will have less than area as compared to green, and this golden will have highest area among all of them. Okay, so you can use the approach of area under curve. Here you can see. Okay, so here you will simply pass recall and precision to that area under curve provided by scalar metric. It's a function you can use there, and you can calculate the area under the curve. Let's say 0.42, this blue curve have area 0.42. And if some other curve, let's say the higher curve like this curve have area, let's say 0.6. So this model is better than this model. Okay, in this way you can compare the models also. Having multiple position recall, you can calculate the score by you can visualize by visualizing the graphs by the curves, and if you want to see in the form of scores, you can use the area under curve. Okay, now we will see the functions that I have used for the whole process in the imported from the sklearn. I will show you here. Okay, the same data here. True values prediction probability belonging to class 1. So here there is a method like binarize. Okay, here you can see there is a method binarize that is imported from the preprocessing. You can use that method binarize uh, if you uh, uh, want to get the threshold or prediction column with respect to some different threshold. Let's say this prediction column is according to the 0.5 threshold. Okay, so now if you want to have a prediction column according to the threshold 0.4, okay, how you can calculate that? There is a binary function, and you will pass the probabilities here, and you will pass the threshold that on which threshold you want to calculate the predictions, and you will run that, and you will see the uh, predictions again according to that mentioned threshold. Okay, by using that approach by using that binarizing function, I have here drawn multiple confusion metrics and position recall scores. Okay, yeah, this is a this function I have here coded, in which each time according to the like here I am passing the threshold 0.1, that function it will calculate the here prediction column according to the 0.1 threshold. Okay, so after predicting the prediction column, you will pass here With the true values, you can calculate the confusion matrix, and you can also calculate the Parisian score and recall score by using the same. Okay, in this way, I have iterated in a loop to see the multiple to pass the multiple threshold and see the multiple confusion matrix and scores. Okay, so in this way, you can use the binarize function to get the prediction according to required threshold. Okay, now there is another method which is precision recall curve that you can also import it from also can import from the Scalar metrics dot matrix. So if you will use that precision recall curve and you will pass here the true values and the probabilities belonging to class one, it will give you three arrays here: thresholds, recalls, precisions. Okay, so what it will do, it will generate multiple thresholds, and against multiple threshold, it will generate multiple prediction columns, and against multiple prediction columns, it will calculate the recalls and precisions. In other words, you can say it will generate multiple thresholds, and against each threshold, it will calculate the recall and precision. Okay, like here you can see it has calculated. First, I can show you here these thresholds. It has uh, generated a multiple thresholds. Here you can see about 300 threshold it has generated here. According to the 300 threshold, it has calculated a lot of recalls here and precisions also. Okay, you can use that precision recall curve to generate multiple thresholds and recalls and precisions. Okay, so here you can see in the documentation of precision recall curve, this is the important one, this one. So there is here it has calculated, if you will see here, there are length of threshold is 300, but the length of precision is 301, and length of recall is also 301. It means that thresholds have 300 values in its array, recall has 301, and precision has 301. And when you will see the reason behind that, you will see from here documentation, the last precision and recall value are 0 and 1 respectively. It has made by itself the last values 1 and 0. Uh, the reason is that so that and do not have corresponding threshold. Okay, so last threshold they have not given in the, let's say there is 301th value in the precision and recall arrays have not their corresponding threshold. Why they have done this in this way? To ensure that the graph will start from the y-axis. Okay, this is the just the reason here. Okay, so here you can see last value of precision is 1. Here you can see last value of precision is 1, and last value of the recalls will be 0. Yeah, here you can see. Okay, they have hard coded this. This function has hard coded these two values. Okay, anyhow, so when you will plot, let's say you will plot thresholds on the x-axis and recall and position on the y-axis, you can see the graph like this. Okay, I have just coded here a function. You can see the graph here. Okay, and let's say according to the requirement, your requirement is a project requirement. You want such a threshold where the precision is 70%. Okay, or greater than 70%. So here I have passing that condition, precision greater or equal to 70%. I want an index at this position. Here 295th index, I have precision greater than 0.7. Okay, so here when I passing this whole, or in other words, the 295 in the thresholds array, I will get 0.69. It means at the 0.69 threshold, I will get the precision 0.7. Okay, in this way you can calculate. So if you want to see the plot or curve in this way, recall on the x-axis, precision on the y-axis, you have both arrows, you can plot easily. Okay, here like I have plotted by using C1. Okay. So, uh, as you know, in the when we use F1 score function by sklearn, it get the values in the form of true values and predictions, okay, like the precision scores and like the recall score. But I have told you here the you can use the formula and you can pass the precision and recall score and you can calculate the F1 score like a 0.23. So in the same way, I have multiple precisions and recall scores and I can calculate the multiple uh, F1 scores. Okay, here I am using formula on that precision and recall arrays and I have generated here multiple F1 scores. So out of all the F1 scores, here I have used the max function and it is saying me 0.49 is the maximum F1 score we have here. So we want a threshold that where the max F1 score we have. So I am using an argmax and it will give me the index. And at that particular index, I will see the threshold and 0.25. So it means at the threshold 0.25, you can have highest F1 score of your curve of your model. Okay. So here you can also visualize when you will plot threshold versus F1 score. Okay, and as I told you, if you want to calculate the area under curve, okay, if instead of visualizing, or if you want to compare multiple models, so this particular, let's say this particular classifier have this curve, so another classifier will have another curve. If you will plot here, so or if you want to see the curves by visualizing the curve that is more towards the top right corner, you will say that this classifier is good. But if you want to see in the form of scores, I have told you you can calculate the area under curve. Okay, here area under curve is also important from Scalar Metrics. So you will pass just recalls and precisions. It will calculate the curve by itself and the area under curve also. And here the area under curve is 0.42. Okay, so in this way, you can have multiple classifiers and multiple classifiers will have their own area under curves and which has the highest area under curve, you can say this model is good. Okay, let's say usually in the project scenario, we have when we started our project after ADA part, we have to select the model, which model will be suitable here. Okay, you can apply multiple models and which model is giving you the best area under curve. You will select that model, and after that, now you will select the threshold for that particular model according to your requirement. Okay, according to requirement, if you have according to required position or according to required recall and or according to the if both are equally important, then you can set the threshold of your selected model, which is giving you highest F1 score. Okay, I hope in this discussion you got a very clear idea how you can use precision and recall, how you can achieve your required accuracies, and how you can compare your models. So, for now, in the next sessions, we will discuss another very important curve, which is ROC curve. So, for now, thank you.